Hello, Ryan.
Hi, sir.
Everything good?
Fine, sir. Thanks.
This is your first class, right?
Yeah.
All right, Ryan. So, what chapters have you completed in school?
In school, you have just it's the matrix is about to complete, but we haven't finished yet.
All right. So, no other chapter.
No.
All right. All right. Uh, so, we have completed matrices, determinant, continuity, differentiability, right? So, relation functions. So, what do you think is better for you? Do you want to start from scratch, or it's okay to continue with the current batch?
Let's continue with the current batch, sir.
All right, all right. So currently we are doing continuity and differentiability. All right. So we have finished the differentiation part. Let me give you an overview. Right. Quick overview. We have. Hello, Sahel.
Hi, sir.
Everything good, Sahel?
All good, sir. What about you?
Everything good. Revised everything.
Yes, sir.
All right, all right. So Ryan, in class 12th, the vast syllabus is calculus. Right? What is calculus? Study of functions. That's it. Right? How to study different types of functions, differentiation of those functions, integration of those functions. This concludes 50 to 60% of your syllabus, and rest of the things are like probability, matrices, determinant, vector 3D. They are different, right? So we have finished, you can say 30 to 40% of this syllabus. All right. And the chapter continuity and differentiability, we have three parts. First is continuity of a function, differentiability of a function, and differentiation. All right. You will get one question out of this, but most of the question will come from this differentiation part. All right. This thing we have completed, differentiation. Continuity we have almost finished. We are going to start differentiability today. All right, time.
Fine, sir.
So if you like want, you can get the recorded lectures also. All right. But if you face any issues that sir, you are not like I'm not able to understand anything, then be very honest. All right, don't hesitate. All right, Ryan.
Yes, sir.
All right. So if you face any issues, just ask, and we can arrange something for you. All right, from scratch. And Sahel, have you practiced some questions or not?
Yes, sir. I've practiced a few.
All right, all right. Any doubts?
No, sir. I did that. The first exercise, the continuity of the chapter.
And you completed that?
Yes, sir. I have completed that.
No issues, right?
Yeah, I chose the most important questions, and then I solved it. I had some doubts. I clarified it through Google. That was not much of a doubt, though. Yeah.
All right, all right. But avoid looking into solutions, right, Sahel? That's
Right.
not good habit.
Right.
You can try 3-4 times. If not solve, then leave the question for 2 days. Then try again. You might like get the answer right. Revise,
Right.
then check. But if you look into the solution directly, then the habit will become very, very permanent. All right.
I'll try to do it, sir.
Hello, Aman.
Hello, sir.
Everything good?
Yes, sir. All good.
I revised everything of the last class.
Yes, sir.
Any doubts?
No.
All right. So we completed continuity, right? Most types of questions we have completed. today this is the last topic of continuity. Then we can start differentiability. Write down continuity of a function or continuity of two functions. All right. Let f and g be two continuous functions in their common domain. What does this mean? There are two functions f and g who are continuous in their common domain. There is a common set of elements in which both of them are continuous. This is our assumption. Then what happens? F plus g will be continuous. F minus g will be continuous.
Hello, sir. Good evening.
Hello, Kenza. Everything good?
Yes, sir.
All right. Were you there in the last class?
No, sir.
No, right? So did you get the lecture video?
Yes, yes, I have asked.
You have asked, but you have not completed, but
No, I've not completed.
all right, but please watch that video, right?
Yes,
Very
yes.
important class. All right. So f into g will be continuous. Just wait, give me 2 minutes, then I'll explain what we are doing today. All right. F upon g will be continuous. G is not equal to 0. All right. In the last class, we studied different types of questions they might ask in continuity, right? How to solve limits in those questions and so on. When you watch that lecture, you will be completely understood everything. Now, if two functions are given, all right, we will not be solving most of the questions like that method. There is new methods also to solve few questions. We are going to discuss that today. All right. So if two functions are there, f and g, which are continuous in their common domain. This is common domain. What this means, there is a set of elements of x in which f and g both are continuous. This is a given assumption. All right, Kinza?
Yes, sir.
Then if you add those two, then the resultant function will also be continuous. You can directly use this result. This is the important part. You don't have to prove their continuity. If you can prove f is continuous, g is continuous, then f plus g will automatically be continuous. You can directly use this result. Same for this, f minus g will be continuous. F into g will be continuous. F upon g will be continuous given that g is not 0. Right? We cannot have 0 in the denominator. Right, everyone?
Yes, sir.
Yes, sir.
All right. So how is this helpful in questions? You can directly use these results and solve many questions. All right. Ryan, understanding little bit?
Yes, sir.
All right. Please note it down. Done, everyone? Sahel, Kinza, Aman,
Yes, sir.
and
Done, sir.
all right.
Yes, sir.
Write down the question. If a function f is defined as f of x equals to x minus 4 modulus upon x minus 4, given that x is not equals to 4, and 0 if x equals to 4, show that f is everywhere continuous except x equals to 4. Write down this question. Don't try to solve it. Just write it down.
Done, sir.
All right. So this is a very important questions, and the questions of this type are also very important. What is the difference between this type and the questions we did previously? They are not asking to show that the function is discontinuous at x equals to 0, x equals to 1. No, they are asking show that f is everywhere continuous, right? What is the difference? Sahel, if I ask you to prove that Haldiram ke samosa mein aloo nahi hai, what you will do? You will go to Haldiram, right? Buy a samosa, check if aloo is in that or not, right?
Right, sir.
But if I ask कि दुनिया के किसी भी समोसे के दुकान में समोसे के अंदर आलू नहीं है, then you cannot go to each and every shop and check the samosa, right?
Right, sir.
Yes or no? Then what you have to do? You have to generalize a solution. And remember this, whenever they ask that show that f is continuous everywhere, you have to generalize the solution. What do I mean by generalizing the solution? You have to assume the cases. All right, always assume cases. Always assume a number k. This thing is clear, everyone?
Yes, sir.
Everyone? All right.
Yes.
Secondly, we can see the question contains modulus function. And Aman, what do we do when we see modulus function? What do we do with modulus function? Sahel, what do we do with modulus function?
I don't remember, sir.
Don't remember. All right, Kinza. You were not there in the last class, although. See, whenever you see modulus function, you just open the modulus function. right? Aman, Sahel, you were there in the last class,
Yes, sir.
Yeah, sir.
right? And Ryan, do you know what modulus function is?
No.
Modulus function is a purifier, RO purifier. All right, it removes every impurity. If I write mod x, if you put 5 in modulus function, the answer is 5. If you put -5, the answer is 5. All right, it's the absolute value. It removes the sign. All right.
What if it's -5 divided by 5?
Sorry, I don't get.
What will happen
Okay.
if you put a division in it?
No worries. If you put -half, it will give half. It just removes the sign. All right.
Okay.
So this is called modulus function. All right. So how to open this? Mod x is opened as x when x is positive, minus x when x is negative. This, please write it down, everyone. Always open mod x like this: x when x is positive, minus x when x is negative. And by x I mean all the masala inside this modulus. If you have x -5, then Sahel, how to open this?
Then we have to put x -5 when x is greater than 0.
When x -5 is greater than or equal to 0,
Okay.
right?
Okay, the whole term, right?
Yes. And minus of x -5 when x -5 is less than or equal to 0, less than 0.
So the real value means the absolute value can be negative.
No. This makes things positive.
No,
We
means
use
like
this.
we wrote
Let me
minus
give you.
x when x is less, right?
Right. So
But
when
in the
x is negative, when x is -5, open as minus x minus -5. So this becomes 5.
okay. Got it.
Right.
Got it.
Ryan, this thing is clear?
Yes, sir.
Right. So we replaced x as x -5. So this thing will also be replaced by x -5. This thing will also be replaced by x -5. So we can simplify this as x -5 when x is greater than or equal to 5, minus x -5 when x is less than 5. Kinza, this thing is clear?
Yes, sir.
All right. Please note it down. Done?
Done, sir.
All right. So now we have the function f of x is mod of x -4 ups -4 when x is not equal to 4. So how to open this modulus function? This will be opened as x -4, right? Directly x when x -4 is greater than or equal to 0. This thing is clear to everyone?
Yes, sir.
All right, Ryan.
Clear, sir.
And this will be opened as minus x -4 and x -4 in the denominator when x -4 is less than 0. We cannot use equality here because they have given equality sign otherwise. And this is 0 when x is equals to 4. Who is not clear about this? How to open this? We can move ahead. Yes or no, everyone?
Yes, sir.
All right. So we can simplify this. So f of x will be equals to x minus 4 upon x minus 4 is 1. And x minus 4 greater than 0 means x is more than 4. This will be equals to minus 1 when x is less than 4. And 0 when x is equals to 4. So that function becomes very simple. When x is more than 4, the function is 1. X is less than 4, function is minus 1. X is equals to 4, function is 0. Now we can solve for continuity. So how to solve?
So
They are
could you
saying in
explain this step again?
How
How did we get 1 minus 1? Yeah, sir. How did we get 1 minus 1?
See, x minus 4 upon x minus 4 is 1, right, Sahil?
Right, sir.
And minus x minus 4 upon x minus 4, this is cancelled
Okay,
out.
so can you do that actually inside the bracket? Like we're just can you do it actually? Is it possible? It's rule wise.
Yes, this is the way to solve modulus function.
Okay.
And like this is not a trick. This is the actual way how things happen in modulus. All right, Sahil?
Right. So we have to
Okay.
form the values for which we have to find the continuity. It won't be given to us.
Yes, in this question, they are saying proof this is continuous for all the numbers without except 0, right?
Got it. So it's
So
like
there
we're
are
forming the question and then finding the answer.
yes. So we are first simplifying the function,
Okay, got
right?
it.
Because we cannot deal with modulus function ever. Whenever you see modulus function, you have to open the modulus function. Remember this. All right, that is why we have solved like 4 or 5 questions of modulus only, right?
Right. So what if there wasn't any modulus and only the values were there, like x minus 4, x minus 4. So we could have directly done.
Yes, we'll solve questions like that also. Don't worry, Sahil. All right.
Sure, sir.
After this, we'll solve 2 questions of that also. Don't worry. All right. So this thing is clear. Don't worry about the future. Just be in the present. All right, Sahil.
Right, sir.
So this thing is clear. Function is very simple now. When x is more than 4, we have 1. X is less than 4, we have minus 1. X is equal to 4, we have 0. Now coming to continuity. Till now we are simplifying the function. Now coming to continuity. Let k be any number. All right. I told you to prove this is continuous for all the numbers except 0, we have to generalize the solution. So k, we are not putting any specific number. We are saying k be any number. So how to divide this in cases? Case 1. We have to divide k according to this definition. First case, k is more than 4. All right. First case, k is more than 4. So if k is more than 4, then what will be f of k? When x is more than 4, what is function? 1?
Yes, sir.
Yes or no? Right. So f of k will be 1. What will be limit x tending to k f of x? Who can tell me? See, this is limit x tending to k. What is f of x? When k is more than 4, what is f of x?
1.
1. So 1 is independent of x. So limiting value will be 1 only. Yes or no? Yes or no, everyone?
Yes, sir.
Sahel, Kinza, this thing is clear?
Yes, sir.
Yes, sir.
All right. Ryan, understanding a little bit? I
Yes,
can
sir.
understand. This can be little tough to understand, right? For the first class. But what can we do? Right? So we have f of k equals to limit f of x extending to k. So we can say function is continuous for k more than 4. Yes or no? Because we have not given k any number. We just said k is more than 4. And we proved that f of k is equals to limit f of x extending to k. So obviously function is continuous for all the values more than 4, right?
Yes,
Or
sir.
no? All right. Now k is less than 4. I'll give you guys 2 minutes. Try to solve for k is less than 4. All right, Sahel. Can you do this or not?
Would it be -1?
Yes. All the functions we have to assume -1. All right. I'll be giving you 2 minutes. Please write down all the steps also. All right. First note it down, then solve for case 2. You have to solve, note it down also the solution. Start from here or no? From here. All right. This is the solution. Start from here. Solve till 1, then try to solve case 2 by yourself. All right, everyone. Kinza, Sahel, Aman, Ryan, yes or no?
Yes, sir.
All right, I'll give you a few minutes.
Sir, can you show case 1?
Solved it, anyone?
Yes, sir.
All right. Kinza, Aman.
No, sir.
When k is less than 4, what is f of x?
-1.
Minus 1. So what will be f of k?
-1.
Minus 1. Very simple. Now we have to find limit x tending to k f of x. Again, what is f of x? Minus 1. So limit -1 x tending to k. So limit of a constant is that same number. Yes or no? This is clear, Kinza, Aman, Ryan.
Yes, sir.
All right. So again, we can say f of k is equals to limit f of x tending to k. So function is continuous for k less than 4. Right? If f of x or f of k is equals to limit f of x tending to k, then we say function is continuous. This we have solved, checked in the previous classes. All right. So what will be case 3? When k is equals to 4. Right? We divided the whole number line into 3 parts: more than 4, less than 4, and equals to 4. So when k is equals to 4, what will be f of k?
0.
Absolutely right. Now to find limit, we have to check right hand limit and left hand limit. Limit x tending to k minus 4 minus f of x. All right. So what will be f of x here? 4 minus 4 minus means less than 4, right? Extending to a little bit less than 4.
Yes, sir.
So what will be f of x?
-1.
Minus 1. So this will be limit extending to 4 minus -1. So what will be the limiting value? The answer of this limit? -1, right? Limit of the constant is same, independent of x. Is it clear to everyone or not? Yes or no? Sahel, Aman, Kinza, Ryan?
Sir, can you explain why are we checking the LHL and RHL in this
Right.
one?
Because when x equals to 4 and finding the limiting value, Sahel, what does limit say? Limit, when finding limit x tending to 4,
Then
we are
why
not
didn't we?
putting,
So for the last two cases, why didn't we do it?
right? Let me tell you, or let's write here. Again, see, when finding limit x tending to 4, we do not put x equals to 4. X is almost 4, right, Sahel?
Right, sir.
So when we had f of x equals to 1, when did we have this? When k is more than 4, right?
Right, sir.
So when you find this limit x tending to k and k is more than 4, right? So the function will not change, right? Function will always be 1 for k is more than 4. If you take right hand limit or left hand limit, yes or no?
It would still be 1.
Right? Because it
Right.
will not change. But here in this case, when k is equals to 4, if you take the left hand limit, So
Right.
k will become slightly less than 4, and as soon as that
Okay.
happens,
Got it.
function will change, right? So we
Yeah.
break into when function changes. All right, Sahel?
Okay. Got it.
Please
So means
look. Yeah, please
okay.
look previous questions. You will be
Right.
clear when we break down and when we don't. All right.
Right. So we can say that whenever there is an equal sign, we have to check in simple terms.
No, you have to check when the function is breaking. This function is breaking at 4, right? Function is
Right.
they have broken down the definition when x equals to 4, when x is not equals to 4. So we have to check at 4 what happens. All right.
Got it, sir. Got it.
So limiting value is -1. Now limit x tending to 4 plus f of x. So what will be f of x here? What will be f of x? 1. So limiting value will also be 1. So we can clearly see limit is not equal. So LHL is not equal to RHL. So function is not continuous at x equals to 4. Everyone is clear about this or not? Aman?
Yes, sir. Understand now.
All right. Sahel, Kinza, Ryan?
Yes, sir.
Clear, sir.
All right. Please note it down. Case 3.
Done, sir.
All right. So try to solve this next question by yourself. Remember, when they ask you to prove something is continuous for all numbers, you have to assume cases. Discuss the continuity of the function f of x, and this is equal to sine 2x upon x if x is less than 0, and x plus 2 if x is more than equals to 0. All right, so again here you have to take cases k more than 0, k less than 0, and k equals to 0. All right, this thing is very easy. You have to check the limit for both because the function is breaking at 0, right, Sahel?
Right, sir.
All right, so I'll give you a few minutes, try to solve this. Kinza, you have to use the set limit here to solve the limit. All right, you have to use sin x upon x is 1, right? Remember this one?
Yes, sir.
So you have to use this limit. If you have sin ax, then you have to make ax here also, right?
Yes, sir.
Please use that. Anyone solve this?
So only the first case then.
First case. All right, I'll give it 2 more minutes to
Yes.
solve this.
We'll do it. Yeah, 1 minute. Done, sir.
All right, let's see. So first case, k is more than 0. Right, I'll try to write this all in one page. So when k is more than 0, what is f of x? What is f of x if k is more than 0? Look at the function
X plus 2.
x plus 2. So f of k will be k plus 2. Very simple. Now limit f of x extending to k. Again, f of x is x plus 2. So extending to k. So this is also k plus 2. This thing is clear? Everyone? Sahel, Kinza, Aman, Ryan.
Yes.
Yes, sir.
So function is continuous for k more than 0. Now for k less than 0, what is f of x? What is f of x here? Very simple it is.
Two.
2 when k is less than 0, you have 2 or sine x, sine 2x by x.
Yeah, it will become 2, right?
So first we have to find f of k.
Okay.
So sine 2k by 2, right? No? Sorry,
Don't we
this is
have to,
k.
so don't we have to solve it for 6 and 2x by x?
Like solve how?
Like we did, right? Sine 2 theta by 2 theta will become 1 2 like that.
Right. But you have to do that when finding limit, right? We are just finding this.
Okay. Got it.
All right. So actually, see, when solving this type of questions, you can directly write the sin x. Let's use that theorem here also. If you don't want to solve this limit and all, you can use that limit for here also. We did write 4 things, right? If f and g are 2 functions continuous in common domain, right? So we know sine 2x is continuous and x is continuous, right? Yes or no, everyone? No, Sahel, Aman, Ginza, Ryan. Sine 2x, I believe you know the graph is continuous. X is a straight line, so this is also continuous. Yes or no?
Right, sir.
Right. So sine, if this is f, this is g, both are continuous, then we can say f upon g is also continuous. So for k is less than or equal to 0, you can write, or you can do this limit thing, x tending to k sine 2x by x. So this is also what? Sine 2k by k. Why will not be doing this? The standard formula, because x is tending to k, right? K is not 0 here. That standard limit is applicable when x is tending to 0. All right, Sahel?
Right, sir.
Right. Direct substitution we have to use if that direct substitution is forming 0 by 0 form or infinite by infinite form, then you have to use something, right? But here k is a number less than 0, negative number, so you can directly put sine 2x upon x sine 2k by k. Yes or no? Why do I feel nobody is understanding this? Aman, Kinza, this thing is clear?
Yes, sir.
sir.
All right. So now k is equals to 0. So what will be f of x? X plus 2, because they have given you equality sign. So f of k will be 2, right? Because k is 0. So x plus 2. Now limit x tending to 0 minus, when less than 0, we have to see sine 2x by x. Now you have to use the standard limit. All right, Sahel? Because x is tending to 0. So if you put sine 2x, sine 0 by 0 is 0 by 0 form. Now you have to use standard limit. So we can do limit x tending to 0 minus sine 2x into 2. So the answer is 2. All right, Sahel, Kinza, Aman, Ryan, this is clear?
Yes, sir.
Yes, sir. Clear.
All right. Why we did this? Because direct substitution was giving us double. Now limit x tending to 0 plus function will be x plus. So you can directly put 0 plus, that means 0. So the answer is 2. So we can see LHL equals to RHL equals to f of k. So limit equals to f of k. So function is continuous for all the numbers. All right. I hope this is clear to everyone. Sahel, Aman, Kinza, Ryan, yes or no?
Yes, sir.
All right, please note it down if you have not. I'll give you a few minutes. Done, everyone?
Yes, sir.
All right. Write down a few questions for homework. Discuss the continuity of the function f of x given by f of x equals to 2x minus 1 if x is less than 0, 2x plus 1 if x is more than equal to 0. This is a homework question. Discuss the continuity of the function f of x given by f of x equals to by x is not equal to 0, 0 when x is equal to 0. This is also a homework question. Note it down, then we'll start differentiability. All right. I hope everyone is clear about continuity. All right. If you are not, please get the previous lectures, revise the notes, check again. All right. And if you still have any doubts, ask me in the next class. Today we're starting differentiability. All right. And Ryan, you are understanding something or not?
Yes, sir.
All right. So you are okay with the current batch, right?
Can you repeat that, sir?
You are okay with the current syllabus, right? In
Yeah.
this batch. All right. So if you want to continue in this batch, then please get the lectures of continuity and differentiability, because in the next chapter also you are going to need everything. All right.
Okay, sir.
So please ask the team to send you the continuity and differentiability lecture from the starting. Please watch all the differentiation part. All right.
Yes,
Continuity and differentiability you can watch later also, but differentiation part you will be needing in the next chapter. All right, Ryan?
Fine, sir.
All right. Note it down, homework question.
So what is that? Discuss the continuity of the function f of x.
Given by. Given by.
Done, sir.
All right. Last topic of this chapter, differentiability. So what is differentiability? Let f be a real valued function in the open interval a comma b and c be a number. C belongs to a comma b, then f of x is called differentiable or derivable. At c, if limit extending to c, f of x minus f of c upon x minus c exists. Note it down. I'll explain what this means.
So what is there after and? Like C minus AB, what is it?
This belongs to C belongs to
Oh, the C
Correct.
belongs to A
A
and B.
comma
Oh,
B.
A, B. Okay.
Yes. How much would you guys rate my handwriting out of 10? 2 or 3?
10.
10. All right.
Sir, are you using a mouse or
No,
a
pen.
pen,
pen
right?
tap. Yes.
Okay.
This is how my handwriting looks in the copy also.
Right.
So 2, fair.
There's room for improvement. It's not that bad though.
All right. Well, thank you for the feedback. I will try to work hard. If
Yeah,
there is
great
room
people
for
don't have the best handwriting, right?
I know. That's why I don't even put any effort, right?
Yeah, it's readable though.
Then it's cool, right?
Yeah, the work is done. That's what you want.
I know. This is the problem since childhood, actually. My teachers reduced my marks in mathematics also for bad handwriting. When we only had to write numbers, they did not even understand the numbers. So
Really, sir?
yes, so I have improved a lot.
Yeah.
All right, so done, everyone?
Yeah, done, sir. Then.
Okay. So very simple. Again, we have to use limits and solve limit questions, right? So what this limit says, x tending to c. If you use direct substitution, then what happens? F of c minus f of c, which is 0, upon c minus c, which is 0. So 0 by 0, right? Sahel?
So once again, can you explain?
See, if you use direct substitution and put x equals to c here in this limit, then f of c, right, numerator becomes f of c
Okay, so it will
minus
become indefinite.
right? So we know how to use limits and solve few questions. So this
Right.
limit, if exists, that means LHL and RHL is equal. Then what we will say? The function is differentiable at C. Very simple,
Right.
right? If you have to find if a function is differentiable at 5, then what you have to do? Find limit x tending to 5
Extend to five.
f of f of x minus f of 5 upon x minus 5. This simple. But
Right.
then you have to break it down, right? Limit x tending to 5 minus and limit tending to 5 plus. All right.
Right, sir.
So if both are equal, then we will say function is differentiable. If both are not equal, function is not differentiable. I hope one is clear about this.
So this is like a condition of continuity.
Yes. All right.
Not much to do with differentiation.
No, not a lot to do with differentiation. Actually, what we differentiated, the next statement is that only this limit is called the derivative of f. All right, or differentiation of f. All right, sir. What this means? We have memorized all the formula. X square is 2x, sin x is cos x, right? Differentiation. But how did they get into the formula? They did this only. They have figured out all the limits and gave you the formula so that we don't have to find the limits always. All right.
Got it, sir.
Kinza, Aman, Ryan.
Yes, sir.
Yes, sir.
All right. Please note it down. This limit is called the derivative of f or differentiation of f, and did by.
So can I scroll it up or minimize it a bit?
You have noted till this point, right?
Yeah, I just want to check once. Yeah, okay, sir.
All right. All right. So next point, limit x tending to c minus f of x, f of c, x minus c. And this is called LHL, right? Left hand limit. But in this case, is called LHD, left hand derivative. All right, just a change of name. And limit x tending to c plus f of x, f of c, x minus c is called RHD, right derivative. Note it down, then we'll solve the question. You can write down another point that f is differentiable at c if LHD equals to RHD at x equals to c. Right. So your ultimate focus should be to remember this, how to write down this. Just keep remembering this, how to write this f of x minus f of c upon x minus c, x tending to c minus and x tending to c plus. If you just write this down correctly, then solve the limit correctly, everything will be done. All right. So memorize this: f of x minus f of c upon x minus c. Tell me when we have written this down. Done, everyone?
Yes.
All right. Write down question. Show that f of x equals to mod x is not differentiable at x equals to 0. All right. So again, whenever you see modulus function, what you have to do? Who can tell me? If you see modulus function, what you have to do?
Open the modulus.
Absolutely right. Very simple. So this modulus will be opened as x when x is more than 0, minus x when x is less than 0. All right, Ryan, this is clear?
Clear, sir.
So now to find differentiability, we have to find LSD. LSD will be limit x tending to c minus. What is c here? We are finding the differentiability as 0. So 0 minus f of x minus f of c. So f of 0 upon x minus c. So 0. This thing is clear or not to everyone?
What would you explain again?
Yes. Look at the formula for LSD. We have limit x tending to c minus f of x minus f of c upon x minus c. Right, Kinza? Yes or no?
Yes, sir.
We are finding the differentiability at x equals to 0. So the value of c here is 0. So I did not do anything, just replace the value of c as 0 in this formula. X tending to 0 minus f of x minus f of 0 x minus 0. Right?
Yes, sir.
Sahel, Aman, this is clear?
Yes, sir.
Yes, sir.
Now you have to solve the limit. So if x is less than 0, 0 minus means less than 0, what is f of x? What is f of x?
Minus x.
Minus x. And what is f of 0?
0.
0 upon x minus 0. So what we have to do to find this limit, you have to put x equals to 0 minus h and h tending to 0. So this will be limit h tending to 0. In the place of x, we have to put 0 minus h minus 0 upon 0 minus h. Yes or no? Yes or no, everyone? You can solve directly also limit, but this is the right way, right? Aman, Sahel, Kinza, Ryan.
Got it, sir.
Yes, sir.
So now opening this brackets, we will get limit h tending to 0. This is minus 0 plus h upon minus h. So this is minus 1. So we got LSD as minus 1. Right. Now same way we can find RSD. Same formula. What will change? X tending to c plus f of x minus f of c upon x minus c. So limit x tending to, this is 0 plus what will be f of x here? What will be f of x?
Positive x.
Positive x. Everything else will remain same, x minus 0. So this we can put x equals to 0 plus h tending to 0. So limit becomes limit h tending to 0, h minus 0 upon h minus 0, which is 1. So we can clearly see LHD is not equals to RHD. So function is not differentiable at x equals to 0. Everyone is clear about this? Yes or no?
Yes, sir.
All right. Rest of you, Aman, Sahel, Ryan.
Yes, sir.
All right, please note it down. So this is very simple. Just find LSD, RSD, and you can solve every question. Note it down.
Done, sir.
All right. So this is all for today's class. You'll be getting an assignment for continuity. Please solve that till the next class. All right.
Yes, sir.
Okay. And in the next class, we'll be taking a test also of continuity itself. Everyone clear? Aman, Sahel? Don't
Yes,
want
sir.
the test? All right. So
Test
prepare
is
for the
on?
test
Okay. On
next class.
next week or next class?
Next class.
Okay, this chapter itself, right?
Yes, continuity and differentiation. All right.
Okay.
All right then. Take care, guys. See you in the next class.